Hello guys, welcome to my YouTube channel. Today we will solve mock quiz 2 questions from machine learning foundation. So the very first question is, if f20 is equal to 1, f prime 20 is equal to 10 and f double prime 20 is equal to 5, then what is the second order approximate value of f10? Enter the answer as integer. So to solve this problem, we will use Taylor series expansion formula, which is f x plus neta d is equal to f x plus neta d f dash x plus neta d ka whole square 1 to factorial f double prime x. So in place of x we will substitute 20, or in place of neta d we will substitute minus 10, because we have to find the value of f20. And how to get f10? By this arrangement, 20 as x and neta d is equal to minus 10, we will get the value of f10. So we simply use this formula. So fx is in place of fx we have substituted f20, and in place of f prime x we have substituted 20. So we will just simply use this formula and substitute the values of the respective values, and you get the answer. Okay, so our answer is 151. So this is a second approach. You can also use this approach as well, but in the lectures this approach has been used, so I have solved this problem using this approach. You can also try this if you want, by using Taylor series expansion. So this is a second order approximation, fx equal to fa plus f prime a x minus a plus f double prime a upon the factorial x minus a का whole square. So to solve this problem is we will find what is fx. So instead of a we will substitute 20 and find the value of fx, what is the expression of fx, and we will get fx, and we have to find the value at x equal to 10. So simply substitute x instead of x we have substituted x equal to 10 and simplify the expression, and we will get 151, which is exactly the same as we have done previously. Okay, so you can also try, but I will suggest use this method because in the lectures it was mentioned. Okay, so proceeding with the next problem. So what is the next problem? x1 is equal to 1 1, x2 is equal to 2 3, and x3 is equal to 3 2, and given expression how to find the C matrix which is covariance matrix expression is given, and this is a mean, how to calculate the mean vector. So this is the formula for if three vectors are given. So we have to find what is the sum of eigenvalues of the covariance matrix C corresponding to given data points x1, x2, x3. So enter the answer correct to 2 decimal accuracy. Okay, so first we will find what is the mean vector. Mean vector we will calculated x1 plus x2 plus x3 divided by 3. So just simply substitute the value of x1, x2, x3 and get the mean vector, which is 2 2 2. Okay, and after this we will calculate the covariance matrix, which is given by this equation 1 by n summation from I is equal to 1 to n xi minus x bar, and then transpose of xi minus x bar. So simply expand this expression for three vectors and get this, and then simply calculate x1 minus x bar, which is minus 1 1, and taken transpose, just substituted this, and x2 minus x bar we substitute this, x3 minus x bar we will get this. Just find the product matrix multiplication. This is a 2 cross 1, and it is 1 cross 2, so we will get 2 cross 2 matrix, which is this. Okay, and simply add these summations, we will get this matrix, and simply we will get covariance matrix, which is this. So for 2 cross 2 matrix, the characteristic equation of C is lambda square minus trace of this matrix. Trace is this simply substitute 2 by 3 plus 2 by 3 lambda plus determinant of this matrix. Okay, so the formula is lambda square minus trace of this matrix C plus determinant of C. Okay, so we will use this formula, trace of C times lambda, and this is constant simply. Okay, so we will use this formula and calculate find the characteristic equation of C. You can also try use this method, C minus lambda I is equal to 0. You can also try this and you get the same as I have got this. So okay, just simplify this and you get this characteristic equation, and by factoring we have get the value of lambda 1 and 1 by 3. So the sum of eigenvalues is 1 plus 1 by 3, which is 4 by 3, which is equal to 1.33 answer. Okay, we have asked to find out the value of sum of eigenvalues, right? So the sum of eigenvalues is 1 plus 1 by 3, which is 1.33. Okay, so going for the next problem, problem number 3. What can be the eigenvalues for a matrix that is both unitary as well as Hermitian? So a matrix that is both unitary and Hermitian is called Hermitian unitary matrix, which is, we can denote this matrix with U. A Hermitian matrix is one that is equal to its own conjugate. Okay, this is a definition of a Hermitian matrix. And a unitary matrix is one that satisfies the condition. And what is the unitary matrix? Which is satisfy this condition. U star is equal to I, or U star U is equal to I, where I is identity matrix. Okay, so the U star is nothing but U transpose then conjugate, or you can say U conjugate then transpose, both are true. Okay, so since U is Hermitian and its eigenvalues are real, Hermitian for Hermitian matrix eigenvalues are real. So since U is unitary as well, so its eigenvalues satisfy this condition, lambda square is equal to 1. So the eigenvalues of a Hermitian unitary matrix satisfy both condition. So Hermitian unitary matrix satisfy this both condition. They must be real because Hermitian matrix eigenvalues of Hermitian matrix are real, so they must be real, and because it is also unitary, so eigenvalues satisfy this condition, so it have magnitude 1. So check for the option. So the eigenvalues can be 1 or minus 1 because magnitude of this is 1. So the options are 0, 1, minus 1. These options are correct, B and C. So going for the next problem. So what is the next problem? Number 4. Consider a matrix A is equal to this. For what value of B is matrix A positive definite? So for matrix to be positive definite, the determinant of 2 cross 2 matrix should be greater than 0. So just simply find out the determinant, which is 16 minus B square greater than 0, and simply factoring this equation and get this, and solving this inequality, you will get B less than 4 and B greater than minus 4, which implies that B lies between minus 4 and 4. So the answer is D option is correct. Okay, so going to the next problem. So consider the data points x1, x2, x3. If we are projecting this data set onto the first principal component, then what is the projected variance? Enter the answer correct to 2 decimal accuracy. So first, what is step 1 for calculating projected variance? So the first step is find the mean vector of the given data points. So we have calculated the mean vector using this formula. Okay, 1 by 3, 1 by 2, 0, 0, 2, 1. Okay, so simply use this formula and get mean vector as 1, 1. Okay, so step 2 is find the covariance matrix C. Okay, so the covariance matrix is calculated using this formula, where in this question x bar is coming. That's why in step 1 I am calculated x bar, mean vector. Okay, so if we expand this formula for from I is equal to 1 to 3, we have to simplify this equation for 3 vectors. So we have just simply calculated and get the covariance matrix as 2 by 3, 1 by 3, 1 by 3, 2 by 3. So now we will find the eigenvalues of C. So the for finding the eigenvalues of C, the characteristic equation of C is this: lambda square minus that formula. What is formula for calculating for determining characteristic equation for 2 cross 2 matrix? Lambda square minus trace of that matrix C times lambda plus determinant of C is equal to 0. So simply use this formula, you can find the characteristic equation. Okay, so you can also try this method, C minus lambda is equal to 0, we will get the same answer. Okay, so we have simplified this equation, and by factoring we will get lambda is equal to 1 and lambda 1 and 1 by 3. So we have to find the projected variance on the for the first principal component. So the largest value of lambda will give PC1, first principal component. So the largest eigenvalue will give first principal component. So the projected variance is maximum of these 2 lambda. So the maximum of these 2 values are 1. So our answer is 1. Okay. So going to solve the next problem, the question number 6. What is the value of the function? This function is given and evaluated at the point obtained after one step of gradient descent, where the current iterate is 1, 1, 1. Assume neta is equal to 1. Enter the answer as integer. So by using gradient descent algorithm, we have this formula: xt plus 1 is equal to xt minus neta del f at x equal to t. So the given x naught is given, this x naught 1, 1, 1, and neta is equal to 1 is also given, and function is given. Okay, this function is given, we have rewritten this. So the value of function at 1, 1, 1 is minus 3. We have calculated this, and and by using gradient descent algorithm, we have x1 is equal to x naught minus, because neta is equal to 1, so we have equal to 1, and del f at x naught. So first we will find what is del f. So we have calculated del f, which is, this is fx, this is fy, partial derivative with respect to y, partial derivative with respect to s, and this is partial derivative with respect to z, where in this question x, y, z are x, this is x1, this is x2, this is z is x3. So we have find the partial derivative with respect to x1, we will get this, and with respect to x2 we will get this equation, and for x3 we will get this, and we have to find the value of del f at x naught. So the x naught, what is, we have simply substituted the x naught value. What is x naught? 1, 1, 1. So in place of x1, x2, x3 we will substitute 1, 1, 1. So we will get this minus 2, minus 2, minus 2. So the from equation 1 we have, what we have, x1 is equal to x naught minus this formula, this equation 1 we can use. So the x1 is equal to 1, 1, 1 minus minus 2, minus 2, minus 2, and x1 is here, x1 is 3, 3, 3. Okay. So for calculating, for determining what is, we have to find what is the value of the function after first iteration. Okay, so the value of the function after first iteration, so after first iteration we have x1 3, 3, 3, and for finding the value of the function we just simply substitute 3, 3, 3, x1 is equal to 3, x2 is equal to 3, x3 is equal to 3, and substitute this value into the given function, and which is and simplify, and we will get minus 27 as our answer. Okay, So going to the next problem. So given three unitary matrices A, B and C, which of the following statements are true? Okay, this is a MSQ question, multiple options can be correct. So we will check what is correct. So ABC is always a unitary matrix. So given ABC is unitary matrices, it is given in question. Okay. So if ABC are unitary matrix, then this property must hold. A star is I, and BB star is equal to I, and C star is equal to I. So check if to check if ABC is unitary matrix or not, we will check if this property hold, because for unitary matrices this property hold. So for ABC we will check this. So ABC, and if we simplify this, we will get C star, B star, A star, and because unitary matrix is already given, C star is equal to I, so this is equal to I, and B star, A star. Then after simplifying this, BB star and BB star is also identity matrix, so we will get A star, and A star is equal to I. So we are getting I. This for this question we are getting I. So we can say ABC is always a unitary matrix. Okay. So for option B, so first option is correct, and because first option is correct, this is not correct, because it is saying ABC may not be a unitary matrix, and we have checked that ABC is always a unitary matrix. So first is correct and D is incorrect. So to check second option, A plus B is a Hermitian matrix. So for A plus B to be Hermitian matrix, this property must hold, because for matrix A to be Hermitian, this property must hold. A is equal to A star. Okay. So for A plus B to be Hermitian, this property must hold from this. So we will check if this is equal to or not. So for random we have taken this, and because it is also given A and B are unitary matrices. So I have taken some counter example where A is equal to I 0 0 I, which is the unitary matrix, and B is also a unitary matrix. Same matrix I have given, B is also a unitary matrix. Because in question it is given A and B both are unitary matrices, so I have taken this example A, B. Okay. So I have added these two matrices A plus B, 2i in diagonal and other 0. So if we calculate A plus B star, so we are getting minus 2i. In diagonal entries we are getting minus 2i. So from this we can say that A plus B does not equal to A plus B star for this question. Okay. So because this property is not hold and does not hold, and this implies that A plus B is not a Hermitian. Okay. So this option is incorrect. A plus B cannot be Hermitian. So now we are checking option number third. So what is option number third? Third is AB, BC, AC are unitary matrices. We have to check. So simple, AB and AB star, if this is identity matrix, then in indication AB as unitary matrices. So AB is equal to B star A star by this property, and this is B star is equal to identity matrix. So A star is equal to I, and this is also we have given A star is equal to I. So AB is unitary matrices. So similarly we can BC and AC also hold from this. If this is true, then BC AC also true. So BC and AC are unitary matrices. So the C option is correct. Okay. So and D I have already told you this is incorrect. So A, B and C are correct options. So going to the next problem, problem number 8. Choose the correct options with respect to square Hermitian matrix A of order n. If A is a Hermitian matrix and K is any real scalar, then K is also a Hermitian matrix. So this is this A is Hermitian matrix. So this property was A star, and if we multiply it where K is any real, so K star, I have checked A star, K star from property A star K star, because K is real, so K star is equal to K, and A is equal to A star because A is Hermitian matrix. Okay, so we are getting K, so K star is equal to K, so K is also a Hermitian matrix because this property holds true. So this implies that K is also a Hermitian matrix. So option A is correct. So we are now we are checking option C. Option B we will see later. First we will check option C. Every diagonal element of matrix A is a real number. So for a Hermitian matrix, we know every diagonal elements of the matrix are real. So this is also correct. Hermitian matrix diagonal elements are real. Okay. So for option D, what is given? The determinant of A can either be real or complex. So we will know that all the eigenvalues are real in case of Hermitian matrix. In case of square Hermitian matrix, all the eigenvalues are real. So and product of eigenvalues are determinant. So because the eigenvalues are real, so determinant of A should be greater than or equal to 0 always. So it always be real. So cannot be complex. So this option is incorrect. And for option B, we have taken this matrix A B C D, some random 2 cross 2 matrix, and we have calculated A star, which is A conjugate, D conjugate, and B conjugate, C conjugate, because A star will be this. A star is nothing but A transpose, conjugate of A transpose. So we have calculated this A star and getting this, and from this you see this property holds. Aij conjugate is equal to Aji. Okay, this holds true, and that's why this option is so correct. You can check. So options A, B, C are correct. So going to the next problem number 9. Find the rank 1 approximation of the matrix A is equal to this matrix corresponding to its largest eigenvalue. So to solve this problem, we will use SVD theorem. So what SVD says, any non-symmetric matrix can be represented this, because A is 3 cross 2, we can represent this as Q1 3 cross 3 sigma 3 cross 2 summation 3 cross 2 and Q2 2 cross 2 transpose. So to find this matrix, symmetric matrix, we will use A transpose, and for finding this Q2 transpose, we will use A transpose A. Okay, so first compute A transpose. So we will computed A transpose, which is this square matrix 3 cross 3 matrix. Since A transpose is diagonal matrix, so because diagonal element, so eigenvalues are 9, 4 and 0. So sigma 1 is equal to square root of lambda 1, which is 3, and sigma 2 is square root of lambda 2, which is 2. So our sigma is 3, because sigma is 3 cross 2 matrix. So 3 cross 2, and all in diagonal we will write this values, singular values. Okay, 3 2. Okay, and for lambda is equal to 9, we will calculated the eigenvector, corresponding eigenvector for A transpose. So if you solve this, A transpose minus lambda A is equal to 0. So we are getting minus 5 0 0 0 0 0 0 0 minus 9, and simply solve this, because x1 is we are getting x1 is equal to 0, and x3 is equal to 0. So we have set x2 is equal to 1 because x2 is a free variable. So we have set x2 is equal to 1 and getting this eigenvector E1. And for A transpose A, because A transpose A is this, and for lambda is equal to 9, we have calculated this vector V2, which is x1 is equal to 0, and we have set x2 is equal to 1 because x2 is free variable. So we will get this vector V2, okay, for A transpose for A transpose A. So and our rank 1 approximation we will computed as follows: this singular value 1 u1 e1 transpose. So this is corresponding to the largest eigenvalue. So this is 3, and u1 we have calculated for A transpose. So eigenvector corresponding to largest eigenvalue for A transpose, which is 0 1 0. So this is V0 1 0 calculated, and compute this, and V1 transpose is 0 1. This is V1, you can say, okay. So which is 0 1, V1 taken transpose, and you can simply calculate, multiply these two matrices, and you get this 0 0 0 3 0 0. So our final answer is this. So going to the next problem, let A be n cross n positive definite matrix, then which among the following statements are correct? A inverse is positive definite, A plus B is positive definite, and if B is positive definite, rank of A is equal to n minus 1, A square is positive definite. So since A is a n cross n positive definite, so determinant of A should be greater than 0. So chunki determinant of A greater than 0, this implies that A is invertible and A inverse exists. So this implies that A inverse is equal to anti-matrix because A inverse exists. Okay, so we taken both sides, and I have taken determinant on both sides of this equation, so which is determinant of A inverse is equal to 1 upon determinant of A, because determinant of A is greater than 0, so this also be greater than 0. So this implies that A inverse is positive definite. Okay, which is very simple question, but I have written down the reasoning behind this. Okay, so A plus B, for option B, A plus B, determinant of A plus B, which is determinant of A plus determinant of B, and because determinant of A greater than 0 and determinant of B is also greater than 0 because both are positive definite, so this implies that A plus B is also positive definite. Okay, B option is also correct. And rank of A is equal to n minus 1. Since determinant of A greater than 0, since A is positive definite, so rank of A is full. Rank of A should be full, which is n, not n minus 1. So option C is false. And A square is implies that determinant of A multiplied by determinant of A greater than 0. So this implies that A square is positive definite. Okay, so this option is correct. This is incorrect. This is also correct. So A, B, and D also not correct. So going to the next problem number 11. Consider the following data points. These data points are given: x1, x2, x3, x4. New projected data points corresponding to the original points in one-dimensional PCs. So we are projecting these data points in one-dimensional space. Okay. So first step is calculated the mean vector. So if I have calculated the mean vector x bar, which is 0 0. So after so our mean vector is 0 0. So step 2 is determine the covariance matrix. Just so simple. Find the covariance matrix by using this formula. You will get this 10 minus 10 10 minus 10 10. Okay. So the characteristic equation of C is simply use the formula I have told you, lambda square minus trace of C plus lambda plus determinant of C equal to 0. Okay, So the characteristic equation of C, you can save a lot of time by using this formula. So the characteristic equation of C is lambda square minus 20 lambda plus 0 is equal to 0, and we have calculated lambda is equal to 20 and lambda is equal to 0. So the largest eigenvalue corresponding to first principal component and PC2 second largest value of lambda will correspond to second principal component. So this correspond to first principal component, this correspond to second principal component. Because second principal component corresponding eigenvalue is 0, it means spread is 0. So no data points should lie on PC2 because spread is 0. We don't want to project that data points on second principal component. So all data points will lie on PC1. Okay. So for lambda 1 is equal to 20, we have calculated the corresponding eigenvector. So which is eigenvector, and we have normalized that eigenvector, which is 1 by root 2 minus 1 1. And because all the x bar terms, because x bar is 0, so remaining terms will be 0, we will simply use this formula x1 transpose u1 multiplied by u1. So if I have if I have calculated this value, I have simplified this equation, we are getting minus 4 4, which is the same as our original data points. So similarly we can calculate x2 tilde. So x2 tilde is also minus 2 2, which is same as our original data point. So you can similarly calculate x3 and x4 tilde, which is same as x3 x4. So if you want to visualize this problem, I have draw some line where our original axis is this x y, and I have draw those points. X1 I have draw, x2 I have draw, x3 I have draw, x4 I have draw, and our mean vector is this x bar, which lies on 0 0 because this was 0. So I have calculated the eigenvector corresponding to PC1. So our first principal component axis of first principal component axis will lie along that vector, that vector, which is 1 by root 2 minus 1 1. So the minus 1 1 where it will lie? It will lie on this. So I have draw a line from there. Okay, I have draw a line for PC1. Okay, so if I have draw, I will see that those data points which are given will already lies on this axis. Already it will lie on this PC1 axis. So there is no need to project those data points. We can simply say that these data points are same. You don't have to calculate if you visualize this problem. Okay, so which is PC1 is this, and PC2 will be perpendicular to PC1. Okay, there is no data points projected on this PC2 because lambda for this PC2 is 0. Lambda for this is something I have calculated. Okay, so all data points will be projected on this axis, which is same as our original data points. Okay, there is no need to project those data points. Okay, so I hope you like this visualization part. Okay, so our next problem is, what is the maximum area of rectangle that can be inscribed in a ellipse of the equation this? Enter the answer correct to decimal accuracy. So which is equation of ellipse? So I have draw equation of ellipse this, and this ellipse equation can be written as x square upon root 2 square plus y square upon 1 square is equal to 1, because we know that equation of ellipse is x square upon a square plus y square upon b square is equal to 1, where this is a comma 0, which is minus a comma 0, and these are b comma 0, and this 0 comma b, and which is 0 comma minus b. Okay, so I have just simply wrote those values, corresponding coordinates. I have written it down, and we have to maximize the area of rectangle inscribed in an ellipse. So I have drawn a rectangle inside this, and taken this length as x and taken this length as y. So because this is from origin and this is x, so total length will be 2x, and which is y, so the total length will be 2y, and so the length into breadth will be our objective function, which is area, 2x into 2y, which is 4xy. So I have to maximize this area, a is equal to 4xy. Instead of this, we are maximizing a square. So either we have to this is same as maximizing a, we can maximize a square, because we don't want a square root, just simply squaring part I want. So instead of y square, I can substitute this value 1 minus x square by 2 and substitute this value a square, and now our objective function is this. So for optima, we have to find derivative of this function, which is in terms of x, so in terms of one variable. So simply find the derivative and calculate the critical value, which is 0, minus 1, 1. So for maximum area we will take x equal to 1. Okay, for maximum area we will take x equal to 1. So for x equal to 1, our y is equal to 1 by root 2. So we can, for the maximum area, the x value is 1 and y is equal to 1 by root 2. So therefore a is equal to 4xy, which is 4 into 1 by multiplied by 1 by root 2, which is 2 root 2, which is nothing but 2.82. So our answer is 2.82. Okay, so that's all question I have solved. So if you like this video, you can subscribe to my channel. Thank you.